This video is about generate the SDTM AE domain. So here is the header for documentation, like the project, the program, the programmers, date, okay, the purpose, like create SDTM AE domain. Then we call the automatic macros because for this coding we need a lot of macros. So first we run the include macro here. Then we want to make empty dataset and sorting micro variables. So I run this macro here. So I want to check the log to make sure everything works fine. Yeah, looks like it's correct. Okay. I also want to check the empty dataset to see if it's already created. Yeah, empty AE, now it's generated. Want to view columns here. Study ID, domain, yeah, all the variables are in here. For the empty dataset, it actually comes from Excel file called SDTM Metadata. I want to show you what it looks like. So this is the metadata. This is the variables metadata. So for AE domain, all the variables come from here, including the type, length, label, the format, all created in the empty dataset. For the sorting list, it comes from this one called AE, right? Like AE. Sorted by sorting variables, like study ID, unique subject ID, AE sequence. Now we want to import the raw data AE because we need it to generate SDTM AE. So I import the raw data. Also, I want to specify the folder to put the SDTM.AE, which one that I will generate. So name SDTM. Then I want to check the empty dataset. Use look. See, all the variables are here, including all the attributes. Now I need to rename all the variables with prefix underscore. So the input dataset is the empty AE, which is generated here. And now we to generate another dataset called empty AE2. All of the variables add prefix underscore. Then I want to check the raw data AE to make sure it's imported in here. Yeah, pro contents of the variables in here. How many observations in AE dataset? 2009. Want to use preprint to print out part of the data. Yeah, a term, yeah, looks correct. I want to import the SDTM DM because we will need some variables from this data. So I leave name datasets because DM is saved in this folder. So for contents, to check the DM variables. So all the variables standardized are in here. Yeah, like RF STDTC, like RF ENDTC. This is very important. Also, how many variables in how many observations in here? 1195. So generate DM temporary data. Then I'm going to merge the raw AE with DM to get study ID, unique subject ID, RF STDTC, RF in DTC, RFP in DTC from the DM. So first, I sort the AE data first. Out AE, okay, by subject number. Then I to merge the AE and the DM. I use in equal A to get data from AE, in equal D to get data from DM. I only keep the variables that I need from DM. Also, I need to rename subject ID equal subject number because in this dataset, actually no subject number anymore, only has subject ID. Actually, same thing, so I rename it. So we can use the by variable here to do the merging. And if A, which means merge left, we want all the observations from AE because observation number in AE is larger than that of DM. So we don't want to lose any AE here. Then I call the format micro. Because for some variables in the AE, we are going to use the control terminology. For example, like AESEV, you need to use like mild, moderate, severe, like AE action taken, like those not changed, those reduced. Also like A outcome. Where is A outcome? Yeah, this A outcome. So like continuing, that's resolved. Okay, we are going to need these three. Now I need to derive AE with an empty dataset. First, options mprint because I want to know the result code in the log for the microvariables. Then I set empty AE2 with raw AE2. For this empty dataset, all of the variables has underscore. And for this one, they don't have underscore in the name, and they have real values in there. When they set together, because all of the names are different, so there will be no overwriting. All of the variables will be listed as a long line. These two microvariables are used to generate the underscore AESTDTC and AE in DTC. The input variable is AESTDTC and AE in DTC. These variables are already in here. For the another two micros are used to generate these two, like DYEST, DYAEN, and this is relative analysis. It's a relative start date, relative end date. So you need to use numerical value of AE start date, AE end date. That's why we drew the transformation here, the input to get these two intermediate variables, and use these variables to get to input here to get these two DYEST and DYAEN. So I will run it, maybe it's clearer. So then I check. So from AESTDTC, we generate underscore AESTDTC. From here, you can see this one, the date is missing. The month and the year are present. So we got 2008 July. This is the standardized format. For this one, UNK, the month is missing, and we got only the year. Okay, for this one, both the month and the year are missing. We are got missing value here. From AE Yang DTC, we got underscore AE Yang DTC. So first one is from 2008. So the right format here. This one only has year, so that we got only the year value here. AEST and AEN is a numerical value of AEST DTC and AEN DTC. It's the numbers. We will use value to get the analysis start relative day, analysis end relative day. Then next, we still need to get more values for the variables. Like for these two, we already got the values in the previous step. So we like underscore AEST dy equal dy AEST. So AEN dy equal dy AEN. For the study ID, domain unique subject ID, we actually the values are already in here in the AE. We just need to set the domain value equal AE. For the AE action taken, ASEV, AE out, we use standardized control terms. So that's the formats we just generated in the previous step. Use the micro. The format we generated the AE action taken, AE severity, AE outcome. We also need to define the epoch. How to define it? We use when AEST start date is between reference end date and reference participation end date, the epoch equal follow up. When AE start date is between reference start date and reference end date is treatment. Else epoch is screening. So now we run this. We want to check the log. Okay, make sure. Yeah, it's good. 2009 observation rate from okay. Now we want to check the epoch value we just generated with proc print. Like epoch here, screening, treatment. You can just look at the AEST dy. The first three values are all negative, and this one is positive, which means the first three, the start date actually is before the reference start date. That's why it's screening. This one is positive, that's why it's treatment. Also, we look at the A out and A out. This one is the original value in the raw data. This one is formatted using the control term. So the result using the control term formatted will become recovered, resolved. Continue will become not recovered. So next, we need to generate the AE sequence. First, we need to sort data by a series of variables like a unique subject ID, AEST dy, AEN dy, AE term, AE severity. So we sort this. Then we need to generate the sequence. Like data AE3 set AE2, but we want to drop this variable because this data already has a variable AE sequence, but it's empty, has no values. We use by, because we sort here, by. We want to return AE sequence. If first dot unit subject ID, then equal 1, else AE sequence equal AE sequence plus 1. Because we want for every unique subject ID, the sequence will start from 1. We want to check if the sequence is assigned correctly. So AE sequence, see, looks like For every new unique subject ID start from 1, then they add it up. Keep. We only want the variables have an underscore in their names, so we use micro to do this. So now the dataset only has this kind of variable names in there. Then we want to set the empty dataset with the AE4. The AE4 only has the variable names with underscore, and also they all have real values in it. The empty AE has the variables that has standardized variable names, but don't have any real value in it. Now we set them together because they don't have real, don't have same name, so they will not overwrite. And also I use the do loop here to make the standardized variables will have the values for the variable names, actually the same except the underscore. So I do this, then I sort the data we just generated and only keep the variables that we want, which means the standardized variables. We don't with the mounted variables with underscore. And I want to sort by the string, sort string. So run this. I can check the log. Yeah, looks like this correct. Then if you want to know what's in the A keep string, what's in the A sort string, you can use put underscore user underscore to check it in the log. See from here, like AE keep string include like study ID, domain, unique subject ID, A sequence, A term, and etc. to AE in DY. The AE sort string include like study ID, unique subject ID, and A sequence. Then we want to check the SDTM AE that we just generated. You can use product contents to check it. This is the sort information sorted by study ID, unique subject ID, AE sequence. These are all the variables in there. They all standardized variables. How many observations? 2009. The raw data has 2009, and SDTM AE also has 2009, so we didn't lose any information. And proc print. This is view of it. If you want to check here, it's okay too from SDTM folder, like SDTM folder, like AE. So this is SDTM AE we just generated. Looks like it's correct. Then we want to compare with our instructor's SDTM AE dataset. That dataset is saved in this folder, so I import that data in, use lib name. Then I want to use proc compare. The base is the one we just generated. The compared dataset is our instructors. So list all. This is the compare result. Variable summary, 17 variables. 2009, 2009, 2009. So observation number are the same. So no unequal values were found. All values compare exactly equal. So that's the result that we want. The next is to generate the XPT file. Use the lib name export. So I use lib name. Also use data step ae.ae. Set this is the source file. So to generate this, let's check the log. Leave name AE export successfully assigned, and 2009 from SDTM AE. Yes, now the XPD file is generated. Okay. Yeah, so this is the whole process of SDTM AE mapping process, we can call that. So first we create the empty dataset, then we merge with the raw data, do all kinds of manipulation and format it. Then we add the sequence number and sort it. Finally generate the XPT file. That's the whole process. Thanks for your watching and have a nice day.